Okay, here we go. Number 1. Represent stationary wave on string PQ. All the points on the string are shown at their maximum displacement. And what are number nodes and the number of antinodes? To determine which node and antinode, we have to draw the equilibrium line here. Okay, so node, the particle is at equilibrium line. That the particle are always stay at that point. So this is node, node, node. Okay, why this part is not a node? Because this part it's going up, it's not stay at the place. Yeah, where nodes is the point or the particle is always stay at the place. Yeah, so we have 1 2 3 4 nodes, and the antinodes are the particle which at maximum displacement 1 2 3. So we have 3 antinodes. So here also maximum displacement, which called minimum displacement. It's a node. Node is at minimum displacement. It's not the loop we're going down. It's the min node. Yeah, it has the same amplitude, has same displacement from its equilibrium position with the loop which going up. Okay, number 2. So this is stationary wave and shown a particle x and y, and what could be the phase difference between point x and y. Recall again about the stationary wave, how the stationary wave form. So the stationary wave form because okay, recall again about how stationary wave form. So it's formed because the incoming wave and its reflected wave are overlap each other, and then this overlap create superposed wave which has greater amplitude, or its amplitude is double. Yeah, it's double from incoming and reflection wave. Yeah, so why if we do a stationary wave, if we demonstrate stationary wave on the string using a string, yeah, the look of stationary wave is this. Yeah, and then it moves like this diagram. Yeah, so here we have the example. Here we have four loops. We have four loops here. 1 2 3 4 loops. Yeah, we have four loops. Okay, look at how the loops are moving. So look at to the first loop and the third loop here. The first and the third loop are going up and going down at the same time. Yeah, at the same time. Yeah, This diagram is shown by this red line, yeah, by this red line. It's going so the first loop and the third loop are going at the same time, going up and down. It means they are going in phase, because no time difference where the two going up and where the two going down. At They are going at the same time. In phase mean it's a 0 degrees. All the particles, any particles at the first loop and the third loop are going in phase. Okay, next to the first loop and the second loop here. So first loop and the second loop are going in opposite direction, where the first loop going up and the second loop are going it's going down. All the particles at the first and second loops are going in opposite direction. So it means the phase difference between the first loop and the second loop are out of phase. And this out of phase refer to 180 degrees. Yeah, 180 degrees. Okay, back to the question. So look at the picture here. Is shown X particle and Y particle. So the particle X and Y are going in opposite direction. There, the phase difference is 180 degrees. Okay, so this is the difference between stationary wave and progressive wave. So stationary wave only has a phase difference 0 and 180 degrees. Yeah, it's different from progressive wave that we have 0 until 360 degrees. Yeah. So number 3, which statement concerning stationary wave is correct? All the particles between two adjacent nodes oscillate in phase. Okay, all particles two adjacent nodes. So where are two adjacent nodes? So this is node and node, so they are adjacent node. So the closest node. Yeah. So all the particles here are going in phase. Okay, right. So all the particles here are going to up at the same time and going down to the same time. It's not like progressive wave where the next particle is waiting the first particle to travel and then it vibrate the second, yeah, and then the second particle just move after the first particle move. Yeah, that's progressive wave. But it's stationary wave, the all particles here are going at the same time. Okay, this is right. Yeah, I think it's the answer is A. Okay, we see another answer. The amplitude of stationary is equal to the amplitude of one. Okay, it's wrong because the amplitude of stationary wave is equal to amplitude of both wave, of the two wave. Yeah. The wavelength of separation of two adjacent nodes. No. So this is two nodes. It's only half wavelength, not full wavelength. There is no displacement of particle at antinode at any time. Whoa, it's wrong because the particle at antinodes, the particle which has displacement. Yeah. So which no displacement, only the particle at node. Which statement concerning, okay, it's the same question. The diagram shows string stretch between fixed point x and y. That is stationary on the string here. Okay, yeah, so we have one loop, two loops, three loops, and four loops. Okay, so this is maybe the incoming wave. So this I'm sorry, this is the stationary wave. That's look like a loop when the stationary is moving. The solid curves show the string at position of maximum displacement. Solid, okay, this is solid curve show the string at, okay. The dash curve show the other position of maximum displacement, yeah, because this part will be going down, yeah. I mean, this is the dash line where the next move, yeah, happen. The straight central dash line show the mean position of the string. The straight dash line here, mean position of the string. Okay. So point S on the string is directly above point P, and point T on the string is directly below Q. Yeah, it's the point, not the particle. So this is show the points, show the place, not the particle. It showed which statement is correct. It showed time later point R on the string will be displaced. Where R? Oh no, this is not. The particle is which lay on R will never be displaced. Point S and T on the string move in opposite directions. See, S and T always going. Yeah, it's right. PQ is one. Okay, it's wrong. Vibrate in phase. 2 points on the string. Okay, we can take 2 points that equal, so the point up and the point down from vibrate. No, yeah, because it needs 180 degree to the particle here. It's going down, so that's out of phase, not in phase. Okay, so the answer B.